Dear students, next topic of your unit 3 is the Poisson distribution. Again, it is a discrete probability distribution, and Poisson distribution, as we have already mentioned in the previous videos, that it is a limiting form of the binomial distribution, and it will become Poisson distribution under the two conditions: when n, the number of trials, is infinitely large, that is n tends to infinity, and the second condition is the probability of success is very very small, that is p tends to 0, and the probability of failure tends to 1. The probability of the Poisson distribution is given by probability x is equal to r. R is any values. It can be 0, 1, 2, 3, 4. So this is e raised to power minus m raised to power r factorial. So the Poisson distribution depends upon only one constant, and that is your m. M is the main parameter on which the Poisson distribution depends. Whereas in the binomial distribution depends upon the two parameters, n and p. But Poisson distribution depends upon only one parameter, that is m. So this is the probability of the Poisson distribution. In the probability we require the number of successes, that is x. This is your x. And the probability. So probability is e raised to power minus m raised to power r over r factorial. What is e? E is a constant having the value 2.71823. It is the base of the system of natural logarithm. Now please see, when the x is equal to r, it is 0. When r is 0, what you will get? Just put this value r is equal to 0. It is e raised to power minus m raised to power 0 over 0 factorial. Since m raised to power 0, anything raised to power 0 you know very well, it is always equal to 1, and 0 factorial is also equal to 1. So always remember that the 0 factorial is always equal to 1. So the first term will become e raised to power minus m raised to power 0 over 0 factorial is equal to e raised to power minus m. Next, when the x is equal to 1, then e raised to power minus m raised to power 1, m raised to power 1, and over 1 factorial. And similarly, e raised to power minus m the square over 2 factorial, and so on. And the total of this probability, sum of the probability, it is equal to 1. If you total it, what you will get? You will get the 1. Then the next is the properties of the Poisson distribution. So the main is, it depends upon, as I've already mentioned. So the properties the first is, it depends only on one parameter, that is m. And what is m? N into p, which is the mean of the binomial distribution. Now, m, the Poisson distribution का जो mean है वो m है, which is np. Variance p m है. So mean or variance of the Poisson distribution are equal, right? The coefficient of skewness, which is gamma 1, is 1 over under root m, and the coefficient of kurtosis is gamma 2 is equal to 1 over m. Skewness tell you whether the curve is symmetrical or not, and kurtosis tells us the bulginess of the curve. Now, the uses or application you can read from your book. Let me take now the applications. Application means the numericals related to the Poisson distribution. So I am taking example 2 to explain the use of the Poisson distribution. So I have, on 4th April, I have already sent you these notes in the form of a PDF in your WhatsApp also. And also I have uploaded the notes on the e-resources of the college website. So you can see the examples there. So question is, find the probability that at most 5 defected fuses will be found in a box of 200 fuses if the experience shows that the 2 2% of such fuses are defective. So please see, P we have to first find out. What is P? It is the probability of the fuse to be defective. It is, how much is the probability? 2%. 2% means 2 over 100, it is 0.02. Another thing which we require is N. N is, in our case, N is 200 because find the probability in a box is having a 200 fuses, so N is 200. So the first thing in the Poisson distribution, to find the probability, we have to find out the M. M is N into P, N is 200 and P is 0.02 and it is equal to 4. Now probability of X is equal to R, we have already mentioned, e raised to power minus m, m raised to power r over r factorial. So it is e raised to power minus 4, 4 raised to power r over 4 factorial, r factorial. Now the first thing which you have to do is, you have to find out e raised to power minus 4. And you at the back of the book, you are given the tables. Please see the table. Values of e raised to power minus m for computing the Poisson distribution. Just see the table. The upper part contains binomial coefficient and the lower part contains the values of e raised to power minus m. In the values of e raised to power minus m, you are having two tables, and here is the value of m. In the first table, when m is in fraction, that is 0, 0.1, 0.2, 0.3, 0.4, all the values are in fraction. So these are the values, table values when the m is in fraction. And in the lower part of the table, when m is a whole number. Here 1, 2, 3, 4. In our case, m is 4. हमारे केस में m कितना है? m is 4. So see the value corresponding to m is equal to 4. It is, yes, 0.01831. So you just first find out e raised to power from the table. Which table you will see? The lower portion. It is 0.11831. This is the value. Now this value you have to see from the table, and then we are asked to find out the probability that at most 5 defective fuses are there. At most 5 means 5 or less than 5. 5 or less than 5. So कौन सी probabilities आएंगी? No defective, 1 defective, 2 defective, 3 defective, 4 defective and 5 defective. At most 5. 5 is also included. So probability of X is less than or equal to 5. So just put the value of probability of 0. Probability of 0, how you will calculate, beta? It is e raised to power minus m, m raised to power 0 over 0 factorial. And in our example, it is equal to e raised to power minus 4 over 4. M is, because m is 4. So m is 4, 4 raised to power 0 over 0 factorial. So what you will get? Only e raised to power minus 4. Similarly, by putting the value of m raised to power 1 over 1 factorial, m the square over 2 factorial, e raised to power minus 4 will come with each of the term. So since e raised to power minus 4 is coming with each of the term, so we can take e raised to power minus 4 as common, and the result, just add these terms and you will get 42.8668. And I have already told what is the value of e raised to power minus 4. The value of e raised to power minus 4 was, as I have already told you, it is 0.01831. So this is the value. Just put this value and multiply. e raised to power minus 4 की वैल्यू मैंने टेबल से पुट कर दी, ये देखो, और इसको मल्टीप्लाई कर दिया ये सम के साथ. यू आर गेटिंग द आंसर. So probability that at the most 5 defective fuses will be there, it is equal to 0.785. So this type of numericals can come. Then let me take another numerical of the Poisson distribution, that is a fitting of Poisson distribution. So fitting we have already done in case of binomial distribution. Fitting we will also discuss in the Poisson distribution. So what you will do is, in the fitting, what you have to find out, whenever the fitting is asked, you have to find out the FE, that is called the expected frequency. And how you will find out the expected frequency? मैं binomial में भी मैंने बताया था. It is capital N into the probability of x is equal to r. Now in our case, n is as it is. What is the probability? Which probability I will use? Since we are dealing with the Poisson distribution, so Poisson distribution की probability आएगी. पहले हम binomial की लिखी थी हमने, अब यहाँ पे Poisson distribution की probability लिखेंगे. ठीक है? So let us see the numerical. Following mistakes per page were given, and the number of mistakes, that is called x, they are 0, 1, 2, 3, 4. So the maximum 4 mistakes they are held. So n, it is your n is equal to 4. Next, small n. This is small n is equal to 4. And the frequency, this is a observed frequency. It is given. The number of pages in which you are having no mistake, it is 211. One mistake, 90 pages, and so on. When you total it, n, you will total it, it is equal to n, it is 325. It means the book has how many pages? 325. So 325 is your capital N. Now, in order to find out the mean, f को हमें x से multiply करेंगे और इसका total find out कर लेंगे. It's 143. हम अर्थमेटिक मीन निकालेंगे x बार, उसका फॉर्मूला होता है समेशन एफ एक्स ओवर समेशन एफ, यू ऑल नो. एंड इन केस ऑफ Poisson distribution, the mean is, what is the mean from the property? It is m. So just find out the mean. It is 0.44. So सबसे पहले हम लोग क्या करेंगे, probability लिखेंगे किसकी, Poisson distribution की. It is e raised to power minus m, m raised to power r over r factorial. तो हमें सबसे पहले m की वैल्यू पुट करनी है. कितनी आई है m की वैल्यू? 0.44. Just put the value and this is the formula. सबसे पहले हम लोग e raised to power minus 0.44 की वैल्यू निकालेंगे from the table. Now 0.44 is a fraction. So please consult your table given at the back of the book. So which value you will see? The value which are given for fractional values. Here 0.0, 0.1, 0.2, 3, 0.4. This is 0.4 and see the column 4. So fourth row, fourth column, and the value which you will get is 0.44 के लिए कितनी वैल्यू आ रही है आपकी? 6440. Just see 6440. क्या देखा आपने? Fourth row, you have to see the fourth row and the fourth column, and the value which you will get is 0.6440. So I have written this value from the table. Now expected frequency, and I have already told whenever you have to find out the expected frequency, you have to multiply the probability with n. Since we are dealing with the Poisson distribution, so किसकी probability आएगी? Poisson की. It is e raised to power minus m, m raised to power r over r factorial. इसको किससे multiply कर देना आपने probability को? n से. So when x is 0, what you will get? n is 325. यहाँ पे n put कीजिए. e raised to power minus m की value put कीजिए, which is 0.644. And m, what is m? m in my case is, m कितना निकाला हमने? 0.44. So 0.44 की पावर कितनी आ जाएगी हमारी? क्योंकि r 0 है, 0 over 0 फैक्टोरियल, ये भी 1 हो जाएगा. 0 फैक्टोरियल भी हमेशा 1 होता है. आंसर इज 299.3. ऐसे ही फिर आपने x इज इक्वल टू 0 लिया, अब x इज इक्वल टू 1 लीजिए, तब आपके पास एक FE आ जाएगा. व्हाट इज FE? एक्सपेक्टेड फ्रीक्वेंसी. and it is equal to 92.1. So go on putting the values 2, 3, कितनी पुट करोगे 4 तक, क्योंकि सबसे ज़्यादा मिस्टेक्स कितनी है 4. So 4 तक आप x की वैल्यूज पुट करोगे, you will get the probabilities and the expected frequencies जो है वो हमारी आ जाएंगी. Since number of pages they cannot be in fraction, so approximation technique is used. First when x is 0 तो 209 आ जाएगा, 92 आ जाएगा, 20 आ जाएगा और 3 आ जाएगा. इनको अगर आपने आंसर चेक करना है, if you want to check the answer, what you will do, just add these frequencies and see what is the answer. So 209 plus 92 plus 20 plus 3, you will get 224. And what is the sum of the observed frequency? 324. And the sum of the observed frequency is 325. You will be getting 324. It's very quite close to 325 because we have done the approximation technique, so that's why the difference is there of 1 unit. 325 आपकी observed frequency का total है, expected frequency का मेरा आ रहा है 325, so it means my answer is correct. So this is all about the Poisson distribution. Thank you. You're most welcome. If you are having doubts, please try to solve more numericals.